In this example problem, we want to determine how many solutions correspond to each of the systems of linear equations below. So essentially, there are three different cases for the number of solutions. One being one solution, which means that the matrix has pivots in all of the columns. And these are the columns to the left of the vertical line. Next, we have infinite number of solutions, which means that there is a row, including the right column, with all zeros. So basically an entire row that contains only zeros. And for the last case, we have no solutions, which means that there is a column that doesn't have a pivot. And so, for example, looking at the first matrix here, these ones are pivots, basically either the first one in the first row or the first one after any zeros. And that is, of course, in reduced echelon form. And now looking at this last row down here, notice how this row contains only zeros, which hence suggests that this matrix has an infinite number of solutions, because we see that even the right column contains a zero at this row, so we will say infinite number of solutions. And now looking at part B here, we can see that we have two pivots in this matrix, and there is a zero on the fourth column in the last row, but there is a non-zero -1 to the right of it in the solution column. So therefore the fourth column simply has no pivot, which of course basically means that this system of linear equations simply has no solutions, since there is a column without a pivot, as well as no zero to the right of the vertical line. And now looking at part C here, we can see that we have three pivots and three columns to the left of the vertical line. So in this case, every column has a pivot, which hence means that there is only one solution for this system of linear equations, which of course corresponds to whenever you have pivots in every single column to the left of the vertical line. So hence, we will say one solution.